Yeah, in the name of the Hasso Plattner Institute, which is nearby, it's my pleasure to welcome all of you to this event. As we know, Hasso Plattner Institute and software engineering, it's our core topic, and for that reason, it's extremely interesting for me, for all of us, how the automotive IT industry considers and thinks about the challenges we will be faced with. For that reason, I also would like to thank my co-hosts for organizing this event. This time we are in the famous Babelsberg Studios, defined by the film industry 100 years ago. And especially this building is an excellent, outstanding building. Over there are more studios, including one that can be filled with water. If you want to record film segments that play underwater, you can do that over there. So enjoy this building. Please feel free to walk around it. And also this campus has a strong history. So please feel free to explore a little bit the FX Babelsberg Studios. Yeah, thank you. And I think, Oliver, we can go over to my talk, because it's also my pleasure to have this first talk. Doesn't work.
Präsenteransicht. Du darfst es nicht rüberschieben.
Ja, muss man.
Pass auf. Das ist Presentation. So, und jetzt.
Fenster.
Where is Presentation Mode? Das ist so eine PowerPoint, ne?
Ja. Nee, das ist ein PDF.
Alles klar, das ist ein PDF. Gut. Das heißt, Sie müssen das tatsächlich rüberschieben.
Und dafür muss es vorher umgeschaltet sein, damit sonst siehst du es nicht mehr.
Ja, wir sind aber drauf. Eine Sekunde. Ja, ist da. Könntest du dich rüberschieben?
Mach mal das Quicktime aus.
Das ist noch ein Video an, ne?
Mach mal.
Ich mach. Alles klar.
Oh ja, da ist es.
Die Technik.
Wunderbar, vielen Dank, Jürgen. Oh, sorry.
So, my talk is entitled "When Machines Start to Program or Program Machines." It's a topic that we are considering a lot recently in the last few months, because from a scientific perspective, it's an outstanding situation, because it's a complete paradigm change in software industry, in software development, in software engineering. For that reason, I want to outline a little bit our current thoughts, and I will also show you a number of challenges we can foresee at this point in time. Artificial intelligence actually showed almost 50 years ago, for one moment, what what we find in our reality today. It was a famous ELIZA chatbot programmed by Joseph Weizenbaum, simulating a conversation between a patient and a psychologist. ELIZA shocked people. For the first time, they believed that a machine actually behaves like a human, because it responded in a way that convinced people that the machine has human capabilities. By the way, it was a short program. It's about, I think, less than 10 pages source code. It was the genius of Joseph Weizenbaum that found out how he can instantiate templates, sentences, and templates for sentences, so that such that it looks like a human conversation. He was, by the way, not happy about this invention. He regretted a lot that he did this work, because he argued, well, it shows me that people can be confused completely by such simple things. Yeah, so he was very unhappy with this work. But what he couldn't know at that time is that today, with large language models, we are really able to simulate, the way humans speak and humans think. So this was 50 years ago, but nowadays we can really do it. Yeah, that's the point here. AI in science fiction we are all familiar with, and in this film studios here, we are very close to this genre. HAL 9000 was maybe the first computer that is still remembered by people, all kind of people, because he spoke to people. Yeah, he answered all the questions. It was actually a kind of ChatGPT at that time, a very narcissistic computer, by the way, but also this outlined how future can be, and key point, future has arrived. So using large language models, we are actually in a position which allows us to have that kind of machine. AI in everyday life is already there. Maybe it was not known by this terminology. AI is all around us. It's built in many devices, and I'm always remembering the autopilot functionality of airplanes. No one would call them artificial intelligence. It's just an autopilot, and we expect that this autopilot controls very well how airplanes come down to the airport. I mentioned this example because it shows that if artificial intelligence built into something useful actually becomes a ordinary tool, something that is not explicitly realized as artificial intelligence, and we are very happy with that. Yeah, we all enjoy intelligent devices, and we all, especially you, are working on intelligent vehicles, for example. So if it's really good, people will not explicitly say, oh, this is an artificial intelligence-driven car or device. They will just use it. They will be very happy, very productive, and they will argue if something goes wrong. Oh, what's going on? So we get used to artificial intelligence, and if it's not working the right way, we immediately detect that something is not as it ought to be. So artificial intelligence for humans is very attractive because we have an easier life at the end. The question of how to define intelligence still remains. It's on the one hand, it's a scientific question. On the other hand, it's a linguistic problem. What is intelligence? It's fuzzily defined and completely inconsistently used in almost all disciplines are slightly different definitions. We use it for concept methods and procedures, just to name a few. What is human intelligence versus a kind of natural intelligence? Is there something like a swarm intelligence? What is machine intelligence? And finally, what is artificial intelligence? I will not go into details of these discussions, but just let me outline. This fungus here shows shows some characteristics and features that could be called intelligent. Yeah, the way it propagates its roots, and it creates satellites of itself. So it's one of the, let's say, most simple organisms that have this capability, which is commonly referred to by intelligence. Now, going on, AI for software engineering. A few years ago at Hasso Plattner Institute, we stated artificial intelligence is changing the way IT solutions are designed, built, and operated, whereby AI is not being limited to specific application areas. It's a general technology, and all industries will definitely be faced with the question how to apply, how to incorporate artificial intelligence in software production processes. By the way, it's not machine learning exclusively. It's not machine learning, it's not deep learning alone. It's a coincidence of a number of inventions and a number of excellent technologies that get available, that are available now, and they are really operative technologies. For example, it's big data management, because big data is a prerequisite for all kind of machine learning. It's sensor technology, because it provides the input, especially real-time input, to intelligent systems. It's machine learning, and more specifically deep learning, that showed to be most powerful with respect to hardware-friendly implementations. That's also a coincidence that computer graphics, GPUs, have or are at a point where they can generally be used. That is, a general computing takes place on GPUs. And this allows us today, for example, to run large language models on server farms, for example. So it's not a deep learning existed a long time before, machine learning as well, even in the 80s. But together with big data and some hardware improvements, in one moment it became clear, oh, right now we can really use it, and we can scale solutions. Also, there's a big improvement, a big insight into how we can program systems, the paradigms how to program systems. Paradigms changed a lot, and this includes, for example, genetic algorithms. That is, by trial and error, you probe 100 million variants of an algorithm to find out the right one that might fit best your constraints. Functional programming, state free of states, has enormous advantages for several kinds of systems. Quantum computing, and finally, recently, very famous generative AI. Generative AI is now as a buzzword that is used in the press, in media, to summarize, let's say, a combination of all these approaches. but it's by coincidence. It's just the right time to combine these technologies. AI for software engineering now raises the question, how does traditional software engineering fit? Just let's ask a simple question, what is traditional software engineering? I will not start to point out all the hundreds of methods developed for software engineering in the past. They have one thing in common. There's one common characteristics. They are human-centered. That is, they are derived from the ways and structures in which we think about systems, about how we handle complexity, how we implement complex systems, how we want to organize these systems. It's basically shaped by human cognition. Object orientation was one of these real cool moves many years ago, when people start to organize complex systems using this class object schema. Or software development methodologies, organize how human developers work on a subject, and software development cycles are defined by the needs and requirements of human teams of developers. So traditional software engineering maybe is not the best blueprint when machines program machines, because they do not have these human characteristics. And insofar, and that's one of the key challenges, we have to think more more openly about how will future software engineering be. Just to give you another example, we as humans, we tend to solve problems by inventing procedural solutions. If then, that's wonderful. A for loop is wonderful, because we can think in these terminologies. Generative AI, however, does it in a completely different way. Generative AI, in combination, of course, with the right knowledge base, can partially replace large parts of procedural implementations just by, let's say, a kind of stochastic and probabilistic approach. Insofar, that's one key point when we say, well, do we really want to do this? But what if the AI-based solution is much better, much faster, much more stable? Then it's obvious that the AI-based solutions, the generative AI solution, will win, will actually be used at the end. But it's, on the other hand, we have to be able to accept that our procedural approaches, which are human-centered, are sometimes right for humans, but when machines program machines, they are not needed anymore, to a certain point, to a certain degree. So we are at in an age where human-centric approaches move toward machine-centric approaches. Machines that generate code based on objectives and constraints, formally or informally specified, do not necessarily mirror human thought processes, human processes about thinking about complexity. So this will be the most fundamental change, that we have to adapt to a situation where we realize machine-centric programming will be different from human-centric programming. Other issues will become much more challenging. For example, software testing, software debugging, software optimization, because at the end, humans will be responsible for the outcome. And that's a little bit the bad point here, that machines will not take on the responsibility from a legal point of view. Humans will be the ones that have to justify their decisions. So that's a little bit one critical point. Also, the DevOps schema will change, especially as the cycles will be much faster, will become maybe in real time, may become real-time cycles. So now coming to an end, I just want to show you some of the research challenges we are going to investigate, or we are already investigating. A very interesting question is, what about programming languages? Programming languages are made from humans for humans. Do machines need human-readable programming languages? Do they really need these languages? Do we even need higher-level programming languages anymore? Or can we somehow get rid of these programming languages, at least partially, were those areas where machines definitely do all the programming stuff? What are the elements of software engineering, of traditional software engineering, that do not change if we use generative AI, if we do this kind of prompt engineering? Because the overall process will be still integrated in an organization, in a company that is human-controlled. How do we deal with established software systems, especially operating systems and middleware, toolkits, frameworks, because they contain all the findings from the last 50, 60 years, and for many reasons it's not a good idea to say, well, we will use different new ones. Maybe in some years AI will write a better operating system. But at this point, we rely on these systems. So we have to find good ways to interface them with generative AI. Generative AI should not be more intelligent than these systems, because this would imply fundamental risks. And how do we keep humans in the loop in the software development process? We need human developers, we need human stakeholders in this process, but how can we better find the right place for them? One technical question at this time we are very actively working on this question is how to find a good interface between generative AI code and human-written code. The question is, how will application programming interfaces look like in the future if we know that the implementation of an API is done by a generative AI system? So the application programming interface has to be much more intelligent, has to include a kind of self-testing facility. This will raise a lot of technical questions. How will future application programming interfaces look like? And finally, how can we ensure traceability, explainability with respect to explainable AI? Because otherwise it will not be accepted in the long run. So these are just a number of selected research challenges. There are much more, and maybe you know much more research challenges as you are in the front row of the development. Yeah, that's all from my side. This was a short overview about generative AI, about future prompt engineers and how they will work together with machines that program machines. Thank you very much.
Thank you, Jürgen.